Hi everybody. So today what we're going to do is we're going to look at another one of the possible equilibria. Now we're going to look at the equilibria of methyl violet. Now what's up with methyl violet? Methyl violet is an indicator, which means it turns different colors in acids or bases. And the formula for it is really complex, so we're going to keep it really simple. We're going to call it HMV over here on the left, and this stuff you can see is yellow, and over here in the dissolved side of things is the MV-1 without the H positive part of things over here, and that is going to be a purple color over here. So what's going to happen if I start to mess with this equilibrium? What's going to change if I start shifting it one way or the other by adding or subtracting different substances. So let's start off by taking a look at what would happen if I were to add hydrochloric acid to this guy here. Now hydrochloric acid, HCl, is not part of this equation at first glance, but one part of hydrochloric acid is part of that equation. What part of HCl is part of that equation? And it's pretty obvious that it's the H part. So what we're really doing by adding hydrochloric acid is we are adding H positive and Cl negative. Now the last time we looked at this, it was the Cl negative that was important, but this time there's no Cl negative at all in there. But this time we're going to be looking at the H positive part of things because there is H positive here. So what do you think is going to happen if I add H positive to this test tube here? What color do you think it's going to turn? Well, keep in mind that what I'm doing is I am making this increase. Lechat's principle says that equilibria resist change, or whatever you do, it's going to try to undo. So if you give it a bunch of H positive, it's going to try to get rid of all of that H positive. How does it get rid of the H positive? It gets rid of it by going to the side that the H positive is not on, which is this yellow side over here. So if I take this guy here and add in a couple of drops of HCl, I can get this guy here to turn to a yellow color. You see that? It's going from purplish to green, a couple more drops here, and I could get that to turn to yellow, and I definitely have a yellow color here now. So by adding in the H positive, I have made this increase. And by increasing, it's going to go to the opposite side of whatever the substance is changing. And so it's going to go to the opposite side, which is the yellow side over here. So that's the first thing that we're going to try. By adding in HCl, it's going to go to the opposite side. Now what we're going to do is we're going to change it again, but this time we are going to add sodium hydroxide, Na and OH. Now what effect do you think NaOH will have on this equilibrium as written here? Now at first glance, you might say to yourself, well, nothing. None of those are Na and none of those are OH, because in reality, NaOH is soluble because of that Na. So in reality, what I'm doing is I'm adding in Na positive and OH negative. But still, this guy here doesn't have anything to do with Na, and this guy here doesn't have anything to do with OH negative. So you might say at first glance that there is no effect whatsoever on this. But remember, OH and H positive are our acid and bases. Every time OH is present with H positive, they react 100% of the way to create H2O. So by adding in OH negative, even though it's not in this formula, what I'm really doing is if I add in OH negative to this, I am really taking the H positive that is there, reacting it with the OH negative in a side reaction to create H2O. So by adding in OH negative to this equilibrium, I am making the amount of H positive in it go down. I am decreasing, I'm stealing away the H positive because I am taking the H positive that is there, I am reacting it with OH negative to create water 100% of the time, and so consequently I am making the H positive go down. So what's going to happen if the H positive goes down? Well, what does Lechat's principle say? if you make a change, it's going to try to undo the change that you did. So if you steal H positive from it, it's going to say, hey, where's my H positive that you just took from me? I want it back. And it's going to try to make more H positive. How does it make more H positive? Well, it goes away from the yellow side over here to the purple side in an effort to make more H positive. So here is our yellow substance. What I'm going to do now is I'm going to add in some hydroxide, which I have right here. I'm going to add in some hydroxide, and when I add in hydroxide to this, we can see that it's going to go from the yellow color here, and it's going to go back to the purple side of things because I have now added in the hydroxide. So by adding in the OH, I have decreased the amount of H positive, and I have sent it over to the side with the H positive by adding that guy in. So consequently, we get a shift in the equilibrium because of that. So remember that if you add, it goes to the opposite, and if you remove, it goes to the same side of whatever species is that you are either adding or removing, as the case may be. And some of these get tricky because it might not look like OH negative has anything to do with this system, but because of acid-base chemistry, by adding in OH negative to a system that already contains H positive, you will get a side reaction where that occurs, and you will be decreasing the amount of acid because you added base to the system.